This is the Amp Hour Podcast, released June 23rd, 2018, episode 397.5. An interview with Loial from Krontech.
Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Loial from Krontech Technologies.
Hey Loial, how you doing?
Pretty good.
We're at Tour Camp again, and well, I saw you walking around with the Kronos 1.4, and so I had to stop and talk, but we've obviously talked before. What are you shooting with this thing?
Here there is an amazing amount that's actually really cool. They were doing a Mentos Coke thing up on the up by main stage over there a little bit earlier. There's these awesome bubbles that are smoke-filled that I've been trying to get footage of. There's an amazing number of swallows around, and they are beautiful on high speed.
Got it. Is that a lot of people using the Kronos for nature stuff?
We've got a certain amount, yeah.
Okay.
There's some beautiful footage that was made by one person of eagles up in Alaska that just was breathtaking.
Yeah, right. You can get like a lot of the micro movements of like feathers and all that stuff.
The whole feathers across the back of the eagle ruffle up and separate from the bird when they're landing because it's just this negative pressure zone beneath them.
That's awesome. Yeah, that's great. That's great. So for people who don't know, we've had David Kronstein on the show before, but could you tell us what the Kronos is and what Krontech is?
The Kronos is Krontech Technologies' first product. It's a high-speed camera that does 1280 by 1024 at 1,000 frames a second. It can go up to about 38,000 frames a second at a small 336 by 96 resolution. It is aimed to be a reasonably priced high-speed camera, so it's attainable for most people, but still very functional, very capable. It has features that are useful for science and industry, external triggering options. It has the ability to synchronize multiple cameras, so you can do things like stereoscopic.
Bullet time in bullet time.
Yeah. And one of the things that we're working on is actually making that happen.
Oh, really? That's great.
That'll be later on.
Yeah. Fans of the show may also remember Will It Mow. That's a common one. I saw there was a reprise of that with, was it Linus that came up?
Yeah, we had Linus in a couple months back now.
Yeah, that was cool.
Really cool. Yeah, we haven't gotten a lot done in the Moham chamber. It's been super busy at work.
Yeah.
We have been.
You guys are cranking. Yeah.
Yeah.
So new products coming out too, or no?
Not anytime soon. It would be stupid if we weren't working on something, but I can't really say if we are or not.
That's okay. Yeah. But the Kronos was a Kickstarter to start with, and now it's just making it productized and manufacturing, right?
And we're also doing some good improvements to it.
Yeah.
Like, for instance, for the last week or so, I've been working on a new demosaic because the current one is not all that great. Though the H.264 that we encode to is pretty good.
What's a demosaic? Sorry.
Oh, sorry. Demosaic, there's no such thing as a color sensor. So what you've got is a Bayer pattern or a color filter over top of the sensor, and you have to recreate all the missing channels.
Really?
So you've got like two green pixels, a red and a blue.
Yeah.
You have to, for the blue channel, recreate green and red. You do that by demosaic or it's another term for it.
It's like compensating, right?
Yeah.
Okay.
And it's a set of filters.
Okay.
Right now we're doing what's called a bilinear interpolation, which is literally just take the average of all the pixels around it, and that generates the colors in between. But the downside of doing that is you always get a zigzag pattern on any line, vertical, horizontal, even on diagonal sometimes.
So like you mean you can't have a perfectly smooth line?
Yeah, if you have a vertical line, it'll do a little stepped pattern back and forth on either side of the line.
It's like the MS Paint effect, right?
Oh yeah, it looks terrible.
Yeah.
But we encode with H.264, which hides about 90% of it. Because the H.264, it's a high frequency component, it disappears first.
Cool.
But now we're getting sort of into some other areas where raw saving is now a thing. It doesn't go through the demosaic, but it's still important to keep the quality up. And higher quality saving we're also sort of pressing for.
Yeah.
So I've been working on a new demosaic. It's based somewhat on what's called AHD, which is a adaptive homogeneity map or something like that.
Sure, yeah.
I'll just say
it's just math, right?
And what that does is it looks for edges and recreates the detail in line with the edges. So for vertical lines, you'd all of a sudden have this nice vertical edge.
Nice.
Very little what's called false color, where you've got an edge that the edge crosses red, then blue in separate areas. It'll produce a fake color there.
Right.
Well, my new demosaic completely gets around that.
That's awesome. So where's this done in the system? Because when David was on the show, I think you walked us through some of the topology or the architecture, but where's the stuff you're working on being done?
So like most high-speed cameras, what we have is an FPGA that deals with high-speed data. So the data coming off the sensor is higher speed than any CPU can handle. We pipe that through an FPGA into a block RAM or into specifically a piece of laptop memory. And that memory buffer is what you see when you play it back. I can play back, forward, and backwards through it.
Oh, that's right. Yeah, and you can do that before you actually export it, right?
Right.
So that you can get the important parts and not the waiting for the important parts.
And then the FPGA plays it back at 60 frames a second or thereabouts. We've actually gotten around that issue. We can now save to about 200 frames per second.
Oh, nice.
Through the main CPU. And the main CPU is doing the encoding. The reason why we do that is the H.264 encoder is very computationally expensive on an FPGA.
Yeah.
But a CPU can have an ASIC or a special piece of hardware. So if we implemented H.264 on the FPGA, not only would we fill our FPGA completely,
right.
it would take about 15 watts while doing it because it takes way more power doing that much computation. And it wouldn't do 60 frames a second. It would probably do 20 frames a second on our hardware.
Okay. So the demosaic you're talking about, though, is done in the front end piece?
It's actually done between the RAM and the CPU. So it gets demosaiced as it comes out of RAM and played back in an RGB space into the CPU.
Okay.
And then the demosaic's happening in there. There are some components of it that have to pay attention to the high-speed data, but most of it's happening on the low-speed side of it. Low being a bit of a stretch.
Sure.
It's about 3 megabit between the CPU, or 3 gigabit between the FPGA and the CPU through its video ports, and versus 17 gigabit from the sensor to the FPGA.
Got it. And so, like when you're working on something like that, is that like C low-level code written for a micro, or is that still FPGA based? Or?
It's for the demosaic. It's Verilog.
Okay.
So it is FPGA logic.
Okay, so there's FPGA logic that's pulling sensor data back out into memory, and then it goes back through the FPGA to get to the FPGA is gatekeeper pretty much, and the traffic director.
The 32 gigs, up to 32 gigs of RAM that we support is all connected to the FPGA.
Okay.
The CPU actually has another gig on it, but it's not part of the video pipeline.
Sure, that's more like the interfacing and usual computer Linux-y stuff.
H.264 encoder uses it as its frame buffer, but that's about it.
Okay.
One of the interesting problems with the FPGA, though, is FPGAs are amazing at doing computation, but they have almost no memory.
Right.
So we've got this amazing 32 gigs of RAM over on the side, but you can't randomly access it.
Oh,
so if you need the 8 pixels around what you're working on, or in my case, I do a 5x5 area, which is 25 pixels, well, you have to keep that in buffers, but you can't buffer more than about a third of a frame on the entire FPGA.
Because that's the built-in RAM in the FPGA logic you're talking about.
So you can get about a third of an image into the RAM.
So why don't they put more RAM into FPGAs then?
Expense.
Yeah, just because they'd rather put the logic in there and then have you deal with the FPGA
We could get an FPGA that has enough RAM to do a full frame. The starting price on those, we've priced them out recently, is about $2,000.
That's so they know that's where the money is.
Oh yeah.
Okay, got it.
And that $2,000 gets you an FPGA with a lot more RAM and a lot more logic.
Okay.
But it's sort of
that's the cost of the camera almost, right? Yeah. That's
not
crazy. That's crazy.
So instead, what I do is it's a pipeline.
Okay.
And my pipeline is, I think it's about 10,000 clock ticks long, and it buffers the image in both block RAMs as a FIFO, as well as through registers that allow it to access asynchronously this whole region of the image.
Yeah.
And so I have about, let's say about 14, 15 lines buffered at any given time. Okay. In multiple planes. So red, green, blue, the green demosaic data comes out first, so it has to buffer that a little longer. Yeah. The black and white has to be buffered, or the Bayer pattern has to be buffered to the end of the entire set of filters.
So this is the idea, is it's all kind of streaming through this
Yep.
device. So even though you say it's only 15 lines, everything's going through there
Yep.
and then getting pushed out.
So if you wanted to view a new frame, all pixels have to run through this buffer every single time it displays.
That's crazy.
But that's not a cost in the FPGA. The FPGA just continuously can
Right.
put out data.
Right.
The pipeline allows it to be, once you have that pipeline fully filled, every clock tick, one more pixel goes in, one more pixel goes out.
Right. And so what is it getting clocked at?
150 megahertz.
Okay, great. And so that's enough to get the super high speed, everything.
And
So- yeah, okay.
there's a large amount of width.
Oh, okay. Yeah. Interesting. So you'd mentioned that Krontech's growing.
Yes.
So how many like FPGA people are there versus other stuff?
We just brought in a new FPGA person that's looking like they're going to be awesome. But we have about, there's 3 of us now that can do FPGA coding. I'm the main one. The new person's going to be the second as well. David was the original FPGA developer. He hasn't worked on a lot lately. He's been working on more of electronics design. And then we have one Linux dev, like low-level driver. We are looking desperately for another one.
Right. This is why, aside from just talking to you about this stuff, I thought it would be good to get you on here. So
We've been having a large amount of difficulty finding somebody who can program low-level Linux, even embedded stuff, even BeagleBone. Actually, if they have BeagleBone experience, it's even better.
yeah, okay.
Because the BeagleBone is a similar platform to the CPU that we're using.
Yep.
It's the same line. Ours has a few video pipeline features that the BeagleBone doesn't have. And what we're looking for is somebody that can really tie together some of the Linux stuff.
Yeah.
We're trying to port our camera to Debian. That's one of the directions we're
Yeah,
going with it.
cool. That's kind of becoming this all-everything platform, huh?
We're using this TI Arago thing from
Built from source, everything.
built from source.
Yeah.
2009.
Yeah.
Hasn't been updated since 2012.
Yeah.
And I mean, we started hitting where we can't SSH into the camera with some
Oh, God.
things because the SSH we can't support anything other than a
Is it
what,
pre-heart
15
bleed type stuff?
oh yeah, oh, way.
Okay, that's
I
good.
mean, is it Diffie-Hellman 1, I think it is, but that's coming out of memory, so I don't remember.
Yeah.
It's a encryption that isn't an encryption anymore. It has been
right,
broken
it's been
for
broken.
like
Okay, I see. That's
8 years or something.
That's not good. I don't know much about security, but I know that that's bad.
There is a reason why we turned off the Ethernet when we actually launched. We had it open. We had it partially working. You couldn't do anything.
Oh, there is a port for it. I'm
There
looking at
is
the
a
camera
port.
right now. Man, this thing's got some heft. I love
Oh, yeah.
this. Yeah. Nice.
Oh, what's great is you can do almost anything to it. We accidentally hit one with a baseball bat.
Accidentally hit one. Okay.
And I don't know if our demo reel is up on YouTube. I bet it is under Cron Technologies. If you see, there's this one point where our lead for production was he hit a gingerbread house with a baseball bat. And it's so awesome because he hits this and he's got the smile on his face because he nailed it. It was a perfect hit.
And this is in slow-mo, obviously, right? Yeah.
Oh, yeah.
Yeah.
And he continues on, the baseball bat goes and hits the camera.
Good Lord.
And we left the camera footage of it being hit in the demo reel.
Yeah.
I wish we had played a bit longer because it's so funny watching our head of production, just his face go
like,
from this great grin to, oh, what have I done? No damage. Absolutely zero damage.
Nice. Even the lens.
The lens, yeah, it was absolutely fine.
Great.
I think it hit just around there's a coax for taking synchronization and it hit right around there and
Got it.
didn't do anything.
Awesome. That's great.
Another time we actually had we got a camera back from Tech, from RMA, effectively. It wasn't, the guys had the camera for a couple days and they dropped it into a filing machine. A machine that does industrial filing like
Oh my God.
a shapes metal.
Yeah.
And this thing got skewered. The whole LCD shattered. The whole lens came off and was powdered in the machine from what I hear.
And yet the body was...
And we got it in and they were just, please fix it, whatever you can do. And we opened it up, we put a new LCD on it, and it worked.
Oh my God.
Everything else was fine.
Wow.
So we replaced the case because there was a bit more damage to the case. We replaced the LCD pretty much at cost or a little bit higher, just for the labor of it.
Yep.
Send it back, works fine.
That's fantastic.
So a good solid build.
Yeah.
They're a little heavy.
Yeah, it's okay. I think that people in the, I think it's still, I mean, like I've seen some of the other cameras, like the Phantom's like one of the big high-speed ones. That thing's huge.
They're huge and so heavy.
Yeah, exactly.
And actually...
and this is like industrial equipment too, right, at this point, so...
Yeah, and if you watch Hydraulic Press Channel, Beyond the Press, did the best review I've ever heard. He's got this amazing use on language. It's totally, very simple, very awesome, very, very to the point.
Yeah.
And he explained that, he's rented Phantoms. He's used them. And they are, you rent your Phantom, you get it, you pull out your laptop, you pull out your lighting, you pull out your power supplies, you get your power to your zone.
Yep.
You get everything hooked up, you spend a half hour getting the software all up and running and everything going. Mm-hmm. And then you're finally able to start setting up your scene.
Right, exactly, your shot, right?
And with our cameras, you pull it out, you wait for a minute for it to boot, and then you're recording.
Yeah.
It's right there. It's right on the screen, right in front of you.
Yeah, that's awesome.
So, and I mean, here I'm at tour camp.
Yeah.
There's power here, but it's pretty much nowhere where we're going to be recording. It's on battery. So I just pull it out and start recording whenever I need.
That's great. Yeah, I'm hoping to try it later. That's really cool.
So back to the Linux
Linux thing, yeah.
We're looking for somebody to do low-level drivers, some kernel development and porting Debian or helping port Debian, because one of the things we want to get into is we're being held up so much by not having Python, and we haven't been able to compile it
for scripting and obviously the scripting, but like for getting other like community members kind of doing stuff, right?
And for hardware development, when I want to test something quickly,
right.
It is. I had Python working on my camera for a bit there, and it was such a night and day change.
Yeah.
Because it takes 10 minutes to write a test bench on Python.
Right.
It takes you like 3 weeks to set up a test bench on C.
Right.
Or C++.
Yep. You can always do get a LabVIEW interface.
Sorry. I've heard stories.
I know. I shouldn't make fun of them too much. They actually are used in a lot of testing situations, but
They are something we probably will support in the future as well, just because they
I'm sure the Python thing would probably help with that too.
Oh, yeah.
Right? So,
We are working on an API that's hopefully going to be out by the end of the summer.
Cool. What are you going to do with that?
Mainly it's remote control from a cell phone or a tablet.
Got it. So app-based control type stuff, yeah.
But as well, it is a full network control, or at first it'll be a full pipeline control, so you can start the camera recording, you can view video, you can save out video. You won't be able to change things right away. That's actually going to be the next stage on the API. At that point, it is you can connect a computer and use the entire camera remotely.
Nice. That's great. You do like remote security, high-speed footage.
Oh, yeah.
Yeah.
Oh, we had
like a trail cam, right?
There is a joke we've been running around the office. We have a bunch of equipment. We're a hack space.
Right.
We have a giant mill in the back. We have soldering equipment, of course, because we have to reflow stuff and adjust boards. We have the Mohem chamber, so we have a nice armored chamber that we can do tests and shenanigans in.
Shenanigans, right.
And then we also have like a lathe and all that.
Yeah.
Well, we were thinking about doing it so that there's a high-speed camera pointed at the tool path of every tool, and if an emergency button is ever hit, it will automatically save and pipe off.
You can see a finger popping off in slow motion, right? Yeah. That's great. Oh, so one more thing about the low-level embedded people. So like that's like so we actually had Robert Nelson and Jason Kreitner on from that from BeagleBone.
Yeah.
So you said that's kind of the realm of. So is it using like the PRU type stuff, or is it more? Is it writing drivers at the Linux level to access stuff in the PRU?
It's the Linux level. Now this CPU doesn't actually have the PRUs. It has, and this is one of those wonderful things for TI. It has a pair of Cortex M3s. We think it's at least 2. The data sheet says there's 2, but we're pretty sure there's more CPUs in there.
They're just hiding in the fabric, huh?
The DMA you have to load a code plug into, and there's it's.
I mean, like if you had the IP, why wouldn't you just use it for a bunch of things? It's like power's not really. They're not like going for super low power, right?
And even if they were, M3s are extremely low power.
Yeah.
So we use the DaVinci platform, which is a 8148.
Okay.
It is a chip made for doing DVRs.
Oh, cool.
So it can take large amounts of video in.
Yeah.
It has dual H.264 encoders and some other really cool features, video pipeline. But that also means that it's not quite a BeagleBone.
Right.
It actually has the same core, the same A8, same SATA controller, more or less.
Right.
A few registers are slightly changed. USB is similar.
So that'll help getting it into the Debian tool or into the Debian paths, but you're not going to just click and go, right?
One of the things holding us back is we can't change the kernel yet. The kernel is locked to this 2.7.36 10-year-old kernel.
Oh, wow. Okay.
Yeah.
Yeah. That's
So-
pretty old.
No Wi-Fi drivers.
Yeah, right.
no-
Oh, they're on like 4 or something, right?
Yeah.
Yeah.
Oh,
That's when Jason and Robert were on. They
Yeah.
were talking about that.
And I was amazed at what the BeagleBone did, because the BeagleBone started at this point. It started with Arago. It started with
Yocto at one point. I
Yocto,
believe. Yeah.
which is effectively Arago made a little bit more open source.
Okay.
Yocto has dropped the support for this level of chip, unfortunately, because I was looking at them.
Yeah.
And the community came together. From what I can tell, the community came together and brought out 3-point-something and then 4-point-something
Got it.
for the BeagleBone.
Got it.
It wasn't TI. TI has dropped those chips, at least
They
that I
still
can tell.
manufacture them, but they don't support them software-wise, right?
And so it has been a bit of a battle. And it's so horrible looking over that fence and seeing the BeagleBone with
Right,
its,
you're like,
its
hey,
new
oh, more
kernels.
connectivity.
And, everything works, and the PRUs are easy to program now.
Right.
Thanks TI. Actually, I have to thank TI. They made their C compiler available for the community on that one.
Okay. So that's an interesting view, though, too, because so obviously, like I said, we talked to those guys about the latest stuff, but this is using chipsets a couple years on, right? So industrial support, like long-term support type stuff, especially in the Linux space. It's like getting outside that ecosystem, unlocking the kernel is really, really critical.
Yep.
So,
Like, we actually just recently fixed a bug. I'm testing on my camera right now that allows high-speed saving of RAW, because we have an A8. It's a good speed CPU. It has a SATA controller that's 3 gigabit. It should be able to save data at a reasonably good rate. And we were bottlenecked to 20 megabit.
because USB? Sounds like USB.
The USB can throw 480 megabit.
Okay.
This was 20, 30 megabit. And we traced it down to copying video from this video pipeline over in the side of the chip, it's using OMX.
Okay.
So OpenMax or OMX saves into a buffer on the CPU and copies that buffer over to the CPU for it to copy over to the peripheral. It was doing it with a mem copy.
Oh, okay.
And it was doing it, arbitrating into the RAM.
So is
for
that's
every
pushing it in,
byte
pushing it back out, pushing it in, pushing
yeah.
it back out, instead of like DMAing
And-
like big chunks and.
The DMAs, from what I can tell, they might be able to do it, but it's really locked down into the kernel. And this is an old kernel, so you can't just tell it to DMA something.
Got it. Okay.
Newer ones wouldn't have this
That's
problem.
interesting. So this is kind of that kind of illustrates to me like the different levels you're operating
Yeah.
at, right? So if you are lower in the not stack, but in like the operating system and doing more manipulation, you have more control, but
mean-
more hassle maybe.
It would be beneficial if we could get to using video for Linux. It was partially supported, but there's a few things missing on it. Live changing of scaling and things like that. OMX was capable of, and it wasn't. So we went with OMX. Had we gone with Linux or video for Linux, we may have the DMAs available because that's now a kernel level, kernel space.
Yep.
We went with OMX, that's user space, it no longer has DMAs.
Got it.
It's a bit of a frustration. Though I can't promise you that it would be able to use DMAs anyways, because I haven't found anything that says you can DMA from RAM to RAM. You can DMA to peripherals.
Yeah.
So, yeah, we're facing a lot of interesting problems. We solved that problem really recently, though, at least we're testing it out to see if it is, which is we found out that the cache was disabled for the block of RAM that the video was enabled in.
Okay.
And the cache was enabled for the video pipeline chips and for the encoders and the DSP, but never for the A8.
Really? Why would they do that?
Why would they ever have video come out of that system? It should be encoded.
Oh, I see. Okay.
So they just
kind of
never-
using it outside of their prescribed specs and.
So hopefully we've just increased our saving speed through SATA from about 20 megabit, 30 megabit, up to about, I think we've been measuring 50 to 100 megabit.
Okay.
Maybe a bit more than that. We still have to test it more.
Yeah. And so that's something where you can just dump it right into a drive, pretty much,
Yeah.
right? That's what you're saying?
But that's one of the areas that another developer would definitely help on.
Right,
is
right.
going through all these different levels and figuring out where something's going wrong. I did a great one. We had our cameras crashing after 18 hours of use.
Just like
One of
random,
those-
like always at 18.
I know, anywhere from about 12 to 24 hours. It would just fail to show video. It would go to a gray screen. The Linux system was all running. Everything looked good. But this video pipeline would fail if you used it for more than about 12 hours continuously or off and on. And what's even more infuriating is as soon as you were watching the debug output, which took us a while to even find, as soon as you were watching it, it would never fail. It would always be fine. So you could leave it for 36 hours with the debugger watching this debug circular buffer. So I figured that it was probably something to do with the circular buffer. It's probably some contention between the M3s getting at this buffer and something deadlocks. So I went to try and remove the debug statements because nobody can ever use them. They're only available on the command line. They're only available if you actually know about them, which TI doesn't even make very clear where they are. And so I I started looking, and there's the code that's running on the M3s. I can't get very deep into it because of NDA, but the M3s are running an OS on them as well.
Really?
In fact,
like a really low level, like a light
Real-time
RTOS.
OS,
Yeah, okay.
What's funny is it's the only Cortex M3 I've ever seen that runs 20 megabytes of code.
Whoa.
I've never seen an M3 with that much address space, let alone code.
Is that...
So
Okay, well, yeah.
it's the video pipeline stuff.
Oh, got
it makes magic happen.
Got it. That's like where you'll pay for a license for whatever that code is, that kind of thing?
It's actually just writing an NDA, but TI, it's hard to get the NDA from them.
Got it, okay.
You have to talk to an engineer in the field and stuff like that. So we found that these debug statements were rather obvious macro, which was calling a 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 function in the OS, the real-time OS, which was calling a macro, and about 5 or 6 more before I gave up and said, all right, I'm turning this macro to null.
Yeah, right.
And we still have debug output a little bit,
Yeah.
a couple lines out of a boot.
Wow.
But it took care of the crashing. So it was something about that.
Yeah.
And yeah, we fiddled around with the code some more, so I'm not going to blame TI for this one.
No, yeah. But it sounds like there's just, like, it's interesting to me because it sounds like, you know, these systems that were driven towards consumer space, DTV type stuff, right? They're not always full baked, but they are getting their stuff done. And now you're dealing with like kind of the technical debt with it and then building it out though.
Yeah.
So that's great. And it sounds like, I mean, that sounds like a really fun challenge for someone who is
It is an amazing
low
challenge.
level. Yeah.
I don't usually like programming all that much. I like hardware. I love I love FPGA development because it's so encapsulated.
Yeah.
Everything you do is this one block, and this one block has like a couple ports out and a couple ports in.
Right.
And you have
Modular
to
everything.
do a beautiful amount of data and problem solving and buffering and all that in this one little block.
Yeah.
And then at the end of the day, when you got that working, or the end of the week when you've got that working, you can put that block away,
Right.
and it's going to work for the
Keep
next
going.
while.
Yep, exactly. Right.
Versus programming like that huge OS thing where we were going through 14 layers of abstraction before I even found the printf that was actually doing anything.
Yeah, that's crazy.
And I didn't find it.
Yeah. So if people are interested, they would. You guys are based up in
Burnaby, Vancouver.
Is that Vancouver?
Vancouver, BC,
Okay,
Canada.
Cool.
And beautiful, most amazing city to live in. Gorgeous area, mountains on one side, ocean on the other. Air's always clear. Traffic's not nuts. We were in the
Nice
Bay
Canadians
Area.
all around you.
Oh yeah, we were
great.
down in the Bay Area, and oh man, they have problems with traffic.
Yes, they do. Yes, they do.
Oh,
Yeah.
Maker Faire was fantastic though.
That's fun. Yeah, I've done that. I saw you guys were there.
Yeah.
Let's talk about your the thing you're wearing around your neck. I will take a picture and try and post it.
Yep.
But what is, if you can give us a little audio picture, what it is?
So I needed a watch.
Okay.
And I hate having things on my wrist. I don't like the feel of them. I don't like the weight.
Yep.
They always hit things and get broken.
Yep.
So I wanted a watch, and I wanted one that fulfills my needs, which is, okay, I'm a little ADHD, you might be able to tell. I need to see everything around me. I hear everything that's going on. One of the problems with that is I also hyperfocus. So I'll get going on code or I'll get working on problems.
Flow, yeah.
And I will realize at 4 a.m. that I haven't had breakfast
Yep.
from the day before.
Yep. That's like me for layout for me. I'm just in it, you know?
So I have this watch, and it is a VFD tube pendant watch, and it runs a little lithium iron phosphate battery and little USB charging, and it has an hourly alarm. So it buzzes if it's not face down.
Right.
It buzzes and notifies me to check the clock. Check what time it is.
It's just a tick. It's a system tick, yeah.
And, do I need to eat? How am I doing? Do I need to drink something? Because
It's almost like a Zen, kind of like a bell, like the recenter, you know?
And I get pissed off at like audio interruptions. If somebody talks to me, I have to deal with it, and it's frustrating. Or if I hear a beep, I don't like it. It bugs me.
Yeah.
But a vibration on my chest, that's fine.
Yeah.
It,
Yeah. And this is like a sandwich construction, sort of.
Yeah.
I mean,
so it's a series of 7 or 6 boards. The top board is just a nameplate, bottom board as well as a nameplate. In between the top board and the battery is a board with the indicators. It's got a LED, which currently isn't working, but a vibrator, some buttons for doing different functions. Then under that is a lithium iron phosphate cell,
yep.
Which is fantastic. I would totally suggest these for other people's projects.
And this has a charger built in as well. You do
I've
USB
got
charging.
And lithium iron phosphate is so wonderful because if you don't want to high-speed charge it, you can just give it a constant current source and cut it off at 3.6 volts.
Nice.
At 3.6 volts,
that's the
it's fully charged.
LiFePO4,
Yeah.
right? Right. So that's, if people know that, that's sometimes tough with the chemistry stuff.
Yeah. And they are safe. When we first got these cells, they're small. They're
they're like camera size.
It's a 15 millimeter diameter and I think 30 millimeters long rounds. I can't remember exactly. It's about 200 milliamp hours, which for its scale is about right, but it was marketed as a 800 milliamp hours from Surefire.
Right.
I love the Chinese manufacturer names.
Yep, that's great.
And so, it was a bit of a lying on the package of what it was capable of, but at the same time, we weren't expecting the 800 milliamp hours. If it was a primary battery or a non-rechargeable battery, it would have been 800 milliamp hours.
Got it.
So, as it is, the 200 milliamp hours is good for the watch for about 3 weeks of standby.
Oh, really? Wow.
4 hours of display time.
Which is like, why would you be checking that? If you're checking the clock that much, you got other issues, right?
And the reason for the display time is it is a vacuum tube.
Right.
It's running a VFD.
Yeah, where do you source these from?
I get them off eBay.
Okay.
They're actually.
Like what were they targeted at initially, though?
They're new old stock from Russia or from the Ukraine.
Sure.
So they were probably military equipment or products from Russia.
And you need to do like a 60 volt boost to get the VFD?
They're a little bit weird electronically. I made my own controller. So it's got a little boost regulator, which is actually a PWM from the CPU.
Okay.
That I pulse on and off a transformer.
Yep.
And my whole magic, what makes that driver so small is I'm only boosting to negative 40 volts the heater.
Heater, okay. So like the cathode?
I heat up, I couple some current down to negative 40 volts. I offset it by the voltage using a 1 to 10 to 1 transformer.
Okay.
So 1 to 1 transformer does the heater. 10 to 1 or 1 to 10 boosts to negative voltage.
Huh. Okay.
And so I've got a bridge rectifier that's offsetting this isolated current loop down for the heater. And then everything else is P-channel MOSFETs on the high side.
That's great.
So it's logic level. It connects to the CPU directly.
That's awesome. And is this the only one in existence, or did you make a couple?
I've made a couple. I'm thinking about making them as a sort of a product. I'm not sure where to go with it, though.
I mean, I would do a Kickstarter or something. Like, this is like, this feels like a, I don't know, this feels like a Time Lord type thing. I don't know, like, it's great. I love the hanging, I love the necklace piece, too. Like, you could make it into a watch if you want. You could make a longer piece.
It would be. I could lay them side by side, so there's a battery and beside the tube instead,
right.
and it would look great.
Yeah.
I don't like watches, but I definitely, if I did a Kickstarter, definitely would be one of the options.
Yeah.
I also have one other idea, which is I want to make a slide rule.
Really?
I want to make a digital slide rule.
Nice.
So it's a full calculator. It's got VFD on there. And you can dial in your times by 10, your decade for the slide rule, and otherwise it's calipers. It slides back and forth on the whole slide rule, reads the position very accurately, and calculates in live time onto the display.
That's great.
I'd probably do that as a third option.
I like that too. The only thing I think about with this is like this stacked construction would be difficult for making a lot of them, right?
It's not bad. It comes in a single panel. So it's
so you snap
almost...
them out and that. Yeah, I get that. I just mean like someone would have to, there is a physical component to the...
If I put it on Kickstarter, I'd give it an option of a kit.
Perfect.
So it comes in parts. You have to probably solder all of 14 lines, which is the tube, onto one of the boards, all through hole. Very simple. And then everything else would be pre-soldered for you. And then you socket
so you do assembly on all the micro and...
Yeah, because some of it is... I've got a 2mm by 2mm accelerometer in there.
Got it.
You can't solder it by hand. Well, okay, I can solder it by hand, but it takes a lot of effort.
A lot of flux.
My microscope out.
Right. And you'd have to support that too then. So And so you, I don't know if you mentioned, this is running MicroPython too?
Yes.
Right.
So the CPU is STM32L462, which is a very nice little microcontroller, low power ST micro. It's got 512K of flash.
Wow.
190.
So maybe a little overkill, I gotta say.
Oh yeah, for a watch. Oh yeah, but the biggest thing is when I got this going, I got MicroPython on after about a week because there was some problems with USB. But once I got that working, it was 1 day to get it going. 1 day to get MicroPython doing a DMA transfer to the VFD, so nothing's happening in software for displaying. The PWMs, it's all addressable in MicroPython space.
That's awesome.
It's all memory mapped.
Yeah.
So all I do is make a library that talks to the hardware.
Right.
And it took me all of a day to get it running.
That's awesome.
And
that'd be great for like if you do a Kickstarter for making hackable and changeable.
You can use it straight out of the box. It'll work.
Yeah.
But if you want, one of the things I wanted to do with this is make a one-time number generator for crypto.
Nice.
Because it's got a full crypto core in it.
Yeah.
It's overkill.
Right.
It's so overkill.
Yeah, but that's kind of the point, right?
Yeah. Oh yeah. And it allows me to play.
Yeah.
And if I find this 1 hour alarm doesn't work, well, I heard about it, another thing for ADHD, which is a 25-minute timer and a 5-minute timer.
Oh, like Pomodoro.
Yeah, that's what it's called.
Right.
I want to build that into the watch.
Right.
So you just
have it like display tomato, right? And that's Pomodoro.
Sure.
Yeah.
And I thought that was really cool. By the way, I have to put a bit of a plug. How to ADHD has an amazing YouTube channel. She is...
That's great. Okay.
Wonderful.
Yeah.
Has done a great job of just giving some good ideas that I use. Like the 1 hour alarm is actually
that's really
kind of an idea off of some of the stuff that she shared.
Got it.
And so it's a neat little project. It's taken me way too long to get to this point. I think it's a little over a year.
Oh, it's a beautiful build though. I really like it. And
nice steampunk aesthetic.
Yeah, exactly. Well, Loial, thanks for telling us all about this stuff. Are you online in public sphere at all?
I am. On Telegram, I'm Loial Otter, LOIALOTTER. Same on Gmail and stuff like that. I mostly hang out on Telegram because it's the easiest platform for me.
Cool.
And you might be able to tell why.
Yeah, right. Great, awesome. Well, thanks for joining us, and we'll have more shows here from Tour Camp.
Thank you.